if you for some reason can't make it when we have these like all online sessions, I'm recording them so you can go back to the Google Classroom and look for the post later. It's kind of went over that a little bit yesterday in the other video. If you watch that, if you didn't, it's fine, no big deal. But you should be keeping up. So every day there should be something there for you to look at. Obviously, spring break starts Thursday, so we're going to try to do something the first 3 days, today, tomorrow, and Wednesday. So we'll be able to can everybody still hear me? Just nod your head. Okay, so everyone should be able to go through there and see the videos after the fact. If you can't make it, like if you're gone somewhere or whatever and you can't make it during this time, then the videos will be there. So you got to figure out a way how you're going to turn in your homework. That's going to be the biggest issue, I think, for most of us, is what are you going to do? We talked about that last week. If you can take a picture and then just submit it into Google Classroom, that's probably the best. But if you have like a tablet that you can share those notes with me, that works too. That actually would be the best. If you could figure out a way to do that, that would work really well. So, but if you don't have that, just take a picture and submit it on Google Classroom. So are there any questions about that? Okay. None?
What's Jordan doing?
No.
Okay.
I don't think there's audio.
All right, so I'm gonna see how this works. Hold on a second. Okay. So you can all see that now, right? And you can see me too. So just like,
yeah.
Okay, so what we're doing today should be pretty much kind of just review type stuff. It's like area, which there'll be, I mean, it's pretty, in its basic form, it's pretty simple, right? Area is always base times the height of a rectangle or square or something like that. But we're going to be dealing with some little different shapes. You're going to have to try to use your best recollections of things we've done previously to maybe help try to determine the area. But obviously, if you when you had the book open, if you haven't downloaded it yet, you'll see on the top of page 31, obviously we have the theorem that says that area is base times the height. So that's pretty simple. If we had like something like a rectangle where everything was, you know, square, and this was 2 and this was 4, I could just take 2 times 4 and obviously get that the area was 8 units squared, right? So no big deal with that. That's basic math. The problem comes in, not the problem, but what we're going to be mostly facing is how am I going to find the area of something that looks like this if I said that's 4 and that's 3? Obviously the height is not 4. That's the distance of that slanted segment. The height has to be something that's straight from one of the bases to the top of the other side. So I have to have a perpendicular segment to determine what that would be. So maybe that height was 3. And then I could find the area of that by just doing 3 times 3 and getting that that's 9 units squared. Okay, so you got to try to find the height in all of these different looking shapes. There's not going to be any easy ones. I'm just warning you. Like there's no squares or rectangles where you're just going to be able to take the base times the height. You're going to have to figure out a way to find the height. So find that altitude to determine the height. Now, the other thing that they're going to do is maybe not give us some of that information, and we're going to have to remember what we've done to find it. Like maybe they just say this is 12, this is 18, but they say this is 60 degrees right there. And they're going to say, okay, find the area of this figure. Well, how am I going to do that? Oops. Because they didn't give me the height, so I've got to figure out a way to find it. Now, before I go any further, as moving forward as part of our homework, you're going to have to turn in your notes. So everybody's writing this stuff down like we always do, of course. And when you turn in your homework, turn in the notes as well, so that I know you're writing these things down, since I can't really see what you're doing. I don't know if you're watching Netflix on the side or what, but you gotta write the stuff down. Okay, so part of your homework, turn in the notes. Anyway, so if I have something that looks like this, but I don't have the height, remember a couple of chapters ago we had a way to find lengths of special triangles, 30, 60, 90 triangles, and 45, 45, 90 triangles. So if you remember, there were two of them, and the two that you need to know for today are the two special triangles. So let's say I had well, Seth's trying to join. Why is he not in here? Let me see if I can do this. There he comes. Seth was late. We won't mark him tardy. All right. So how do I find the lengths of these this special triangle? Well, if they told me the length of the side opposite the 30-degree angle, I won't make it X. Let's make it easy. Let's say that I said that was 4. If they just told me that, I could find the other sides. Remember that if I have the side opposite the 30-degree angle is 4, then the hypotenuse in this case would be 2 times that. So this side would be 8. And then the side opposite the 60-degree angle would be whatever the shortest side is times root 3. So that you have to remember that from the previous chapters of these special right triangles. So the general one would be like this. Here's my 30, here's my 60, the 90. If the side opposite the 30-degree angle is X, the hypotenuse is 2X, and the side opposite the 60-degree angle would be X root 3. Okay, so go back to my example there on the top. If the hypotenuse in this case is 12, that side is 30, then I know that the side opposite the 30-degree angle is half the hypotenuse, so that would be 6. And then the leg, the altitude that I'm actually looking for would be that short leg, 6 times root 3. Okay, now I can find the area by taking the base times the height. Well, what's the base? It's 18 times that leg. So 18 times 6, you can do the math there. 18 times 6, 108. Now, sometimes they'll ask for an approximation. So if I do that and then I say, okay, let's do square root of 3 times 108. They might ask for like to the nearest tenth. In that case, it would be I don't know if you can see that. Okay. So look what it says. I think most of them are going to say find to the nearest tenth. So if you have something like that, that's what we're doing. Okay. Any questions on that? I'm going to unmute everybody for a second. Where is that? Unmute everybody. Well, I'll do it this way. Okay, everybody's unmuted. Anybody have a question on that? Nobody?
No.
No.
Okay.
No.
Okay. Be quiet. Mute again. All right, they might give us some weird looking shapes. So let's go back here. So they might give us a bunch of different looking shapes, like there's an example in here where they have things like broken up, kind of like this. Doing my best to recreate drawings, you know how that goes. So it's like a floor plan, kind of like a building where they said like this is like a closet. This is like the kitchen. This is like a hallway. Bathroom, whatever, you get the idea. But then they give me some of the links like this. That's a 7. And then it's going to ask you to find like the area of certain things, you know, like find the area of the living room or something. I didn't write that down, but this is the living room right here. So, you know, you're going to have to figure that out based on the information that they give you. So if they gave us something like that and they said that this was over here was 9, you know, I'm just going to have to kind of look at the diagram and say, okay, well, the living room is, if I see this side, like that's 9 from here to here. And this height, sorry, did that wrong. This height is 9. And this height, this side is 15. So 9 times 15, that's going to give me the area of the living room. So you'll have these kinds of diagrams where we might have to like use addition and subtraction to figure out what each length of each side is based on that. Okay, the last thing that you'll need to know is like some coordinate geometry stuff. So they're going to have you draw and diagram things in a graph. Like you'll have a figure and a graph. So here is my graph. They asked me to draw a quadrilateral that has these points: A, B, C, and D. Okay, so it says to graph it, so I'm actually going to graph it. So point A, 1, 2, 3, 4, 1, 2, 3. There's A. B is 2, 3, 2 minus 3. C is 4 minus 6. And D is minus 2 minus 6. Okay, and then it's going to say determine whether the quadrilateral is a square, rectangle, or parallelogram. And I can't do that just based on what it looks like, of course. That's not how we do it. So how would I determine if this was a square? Well, let's start with, we'll start with the square, I guess. That would be the hardest for it to be, has the most requirements. So in that case, the opposite sides would have to be parallel, right? That's for sure, number 1. If it was a square, the opposite sides would have to be parallel. So A and B, segment AB, this segment right here, that would have to be parallel to that segment. How would I find that? Find the slope. And if the slopes are the same, they're parallel, right? So how do I find the slope? You know, y2 minus y1 over x2 minus y2. So if I'm finding the slope of like AB, I would take minus 3 minus a minus 3 over minus 4 minus 2. And so that would give me 0 over minus 6. So that AB segment has a slope of 0. So DC, I would do the same thing, and I would find out if I did that, that slope is also 0. So those two lines are parallel. For it to be a square, the other two would have to be parallel as well, these two over here. So AD would have to be parallel to BC. I'd find the slope. Now, in order for it to be a square, they also have to be perpendicular. So I would need to take the slope of AB and compare it to the slope of like BC. How do I know if they're perpendicular? They would be negative reciprocals. Shake your head if you remember that. Yes. So if let's say that since AB is flat, it has a slope of 0, it's a horizontal line, what would the slope of BC have to be if it was perpendicular? It'd have to be straight up and down, right? So that has a slope would be undefined, where 0 would be in the denominator. But just for purposes of making sure we know what we're talking about, let's say AB had a slope of 1/2. What would the slope of BC have to be in order for them to be perpendicular? You would take the negative reciprocal. Remember that? I flip them over and make it negative. So if their slopes were like that, where AB was 1/2 and BC was minus 2 over 1, those two segments would be perpendicular. But in this case, if I were to do the slope for BC, I'm going to find that the slope of that is, if I were to do it like the other ones, I would get that the slope is 3 over minus 2. So those are not negative reciprocals of each other. 0 and 3 over minus 2 are not negative reciprocals. So those two things are not perpendicular. But BC, if I found the slope of AD, I would find it to be the same, 3 over negative 2. So BC and AD are parallel as well. They're just not perpendicular. So go back to the question. Is this a quadrilateral? Is this quadrilateral a square, rectangle, or parallelogram? Well, it can't be a square. It can't, because they're not perpendicular. It can't be a rectangle for the same reason. So this is a parallelogram because the opposite sides are parallel. There's a misspelling just to keep it real, right? Okay. Spell that on your own. That's a parallelogram because the opposite sides, the purple sides are parallel and the yellow sides are parallel. So if it was a rectangle, they would have negative reciprocals of each other. AB would be a negative reciprocal of BC. If it was a square, how would I determine if it was a square? All the sides would have to be the same length, right? How do I find the length of a side? Distance formula. Yes. So if I got, the easiest thing to show is if they're a parallelogram. So find the slopes first. Then next, if it's a rectangle, they'll be negative reciprocals. They'll be perpendicular. You'd say, okay, yes, it's a rectangle. Is it a square? Then I'd have to use the distance formula to find out if all the sides were the same distance. So that's how you're going to use our previous information. Two huge points that we have to remember. One, when I'm finding areas, I need to remember this right here. These, oh, I'll put the other one. I didn't put the other one in here. Glad I came back. The other special triangle we had was a 45, 45, 90 right triangle. So if I had a situation where that side was X, that's an isosceles triangle, right? Because the base angles are 45. So the two legs are obviously the same. So in this case, I would be easily find the legs they're just equal to each other. And the hypotenuse would be the leg times root 2. Remember that one? That one's the easier one, I think. When I have a 45, 45, 90 right, or 45, 45 right triangle, the legs are the same, and the hypotenuse is the leg times the root 2. So when I need to find the area of that, so these are pretty big things to know. This is important to know, and this, you'll need that. You'll see why in 1 second. I'll do a problem with you. And then you need to know this, that if segments are perpendicular to each other, their slopes are negative reciprocals. And there's an example of what that means. 1/2 and -2/1 are negative reciprocals of each other. So those two segments would be perpendicular. All right, and then the distance formula, you all remember that. If you don't, it's in the book. Okay, so here's one problem that I'll just show you what we're doing. Number 7. So I'm doing one for you. I think this is part of the homework today. So number 7 has a diagram that looks like this. Okay, so I've got the base is 30 inches. One of the sides is 10 inches, and there's a 60-degree angle in there, which tells me they want me to remember our facts about those special triangles. It says find the perimeter. The perimeter, all I have to do to find the perimeter is just take all the sides and add them together. So the distance around that figure is the perimeter. So the perimeter would be 30 plus 10 plus another 30 for the bottom plus another 10 for the side. That's 60, 70, 80. So the perimeter is all the sides added together. No problem there. Okay. The next part says find the area. Well, I need to know the length of this segment. If I'm going to find the area, I've got to know how tall this thing is. So this is a 30, 60, 90 triangle. So I'm going to have to go back up here and look, if you don't remember what that is. There's my 30, 60, 90 right triangle on the right. It says, okay, the side opposite the 30-degree angle is, the hypotenuse is twice that. So let's go back up to my problem here. That's a 30-degree angle, obviously. So the side on the bottom there, from the corner to the right, my altitude is half the hypotenuse. So that's 5. Okay. And the length of the altitude is that distance times root 3. Okay. Everyone good how I got that? So now I can find the area. 30 times 5 root 3. So area is equal to base times the height, obviously. So in this case, area is going to be 30 times the height. So that's my exact answer. Okay. But I need an approximation because it says round to the nearest 10th if necessary. So find that root 3, the square root of 3 times 150 is 259.8. All right. So
Stay safe out there.
you're all talking. I should have. How can we? All right. Any questions? Anybody?
Pretty basic.
Pretty basic. Exactly.
Yep.
Yeah.
Okay. So the homework today, you'll want to know that. What did I do with that? Homework for today. I'll post this on the Google Classroom, but 7 through 24 all. I did one of them for you. 7 through 24 all. So you can turn that in on Wednesday if you want. If you need to take time to figure out how you're going to do that. 7 through 24 all. I'll post that. 7 to 24 all. There's going to be a quiz.
Luke is raising
There's
his
going to
hand.
be a quiz on Wednesday. Quiz on Wednesday because, and with this being kind of easy, hopefully everyone will do really good on that because that's one thing that all of you can help improve your grade is the quiz score. So there's quiz categories. So there'll be a quiz on Wednesday to help
Oh wait,
us
we're actually
in the
having a quiz
quarter.
on Wednesday.
Okay? So the homework will do Wednesday, the quiz on Wednesday, and I'll post another assignment and another video for 11-2 by tomorrow morning. Happy dog.
Who's that?
It's
All right.
Coach.
Going to school?
Questions?
Yeah.
Any questions?
Good job, everybody.
Hey,
Pastor Steve, happy to join your class.
yeah, good.
Hey,
How do you want us to turn in our notes?
You just turn in your notes as part of the assignment. So just take a picture of your notes and take a picture of the problems you do and turn them in together.
Okay.
Okay? Seth, you might have missed that when you came in late. You have part of your homework is you have to take a picture of your notes as well as the problems that you're doing.
Okay.
All
Yeah, I
right.
couldn't figure out how to join, and then it wouldn't let me join.
I had to accept you. Sorry.
Yeah, it's okay. It's okay.
Okay. I'm gonna have to go buy
We'll
an
see
iPad.
everyone Wednesday. Tomorrow you
Go
don't
buy
have
an iPad.
class plan, but Wednesday we will join at the same time, 9:30.
Okay.
Wait.
What?
Wait, do we have class tomorrow?
No, I'm just gonna post a video tomorrow.
Oh. What about
Okay.
and then wait. Okay, tomorrow.
Oh, that beautiful quality.
Tomorrow is okay.
That
video
beautiful
only,
quality.
And then Wednesday at 9:30 to take the quiz.
We turn them in on Google Classroom.
And Nick, you know what we should do? We should just stay in
Wait,
this
how
call
are
and
we
then
gonna
finish
take
the
quiz?
assignment.
I'm gonna
Or
give
should
you.
just start
I'll
our own
post it. I'll
Now let's
show
just
you,
join
I'll
the
post it.
Nick. Let's
Paige,
just start a
what was your
Discord
question?
call.
Yes.
Okay, let's go.
Paige, what's your question?
Do we turn them in on Google Classroom?
Yeah, so submit it on Google Classroom. So
Okay.
you could take a picture, or if you have a notes app, you can share it with me. But if you're just doing it on paper, that's fine.
Okay.
Okay. I can't see some of you, but like, is anybody going to have like do their homework on like a notes app?
I'm gonna try.
I don't have an iPad.
No.
Coach.
Yeah, I don't have the setting to do it.
That's okay.
I don't know how to do it. It's too
might
Well, I'll
technologically
just show you real fast if I can do that.
Currently, my computer won't turn on.
The
I
coach.
mean, I could just type my answer to Google Classroom, to a Google document, and then you could.
You could. It's going to be hard to type stuff. So see this little dude up here?
Then just
How do I text somebody?
If you push that little guy up there, you can share your notes with me right there. So if you have an iPad you have it on, share it that way. Right?
Where's
Yep.
Nick?
Text me.
Oh, it's quiet.
If you have questions, text me or email me. All right, that's it. Have fun.
All right.
Coming home. Peace out.
Thank you, Coach.
This is so weird.
great day.
Okay.
Bye.
Bye, Katie. Bye.
Well,
Late.
yeah. Wait, coach.
Yeah.
So if we're doing
Press the link.
pictures, are we
I
supposed
found
to
it.
do
Thank
it
you.
in horizontal segments or just one vertical?
Say that again.
Are we supposed to do it into like segments like this? Or are we supposed to do it like one big one like that?
For turning in your homework?
Yeah.
One big one's fine because I can blow it up.
Okay.
It'd probably be, it's in fact, do it as one big one would be easier.
Okay.
Okay. Anything else?
Coach.
Yeah.
Is the videos, are you going to post them on the YouTube or on Google Classroom?
Both. Both.
All right.
Yep. So the link to the video will be in Google Classroom.
All right.
Just like the other one was. Okay. That's it. Have a good day. Peace out.